Chapter 3 Chemical Kinetics 12th Chemistry, and we have important questions for board exam. Let us see. Choose the correct answer. For most of reactions, the value of temperature coefficient lies between 2 and 3. First order reaction gets completed to 75% in 32 minutes. How much time would have been required for 50%? It is half time. It means it is half of 32, that is 16 minutes. Plants prepare starch in the process of photosynthesis. First order reaction, the specific reaction constant depends on temperature. In the reaction between A and B to form C, A represents first order reaction and B represents second order reaction. Rate equation will be written as A is first order, so the power of A is 1, which is not written but it is initially present, and the order of B is second, so the power of B is 2. This is correct answer. Rate K equal to A, B raised to power 2. RNS equation is, that is K equal to A E minus EA upon RT. Again see here, this is K equal to A E minus EA upon RT. Unit of velocity constant of first order reaction is per second or second inverse. Next question is, rate constant of reaction increased with the increase of which of the following factor? Temperature, factor on which the rate constant of first order reaction does not depend. It does not depend on concentration of reactants. Minimum energy required for molecules to react is called activation energy. Now fill in the blanks. The rate of reaction does not depend on the concentration of reacting species. Then the reaction of zero order. Half-life period of radioactive element is 140 days. On taking 1 gram element, initially the amount left after 560 days will be 12 gram. Fast reactions are completed in less than 10 to power, 10 to power minus 9 seconds. Unit of rate constant for third order reaction is mole minus 2 liter to second inverse. Difference in the minimum and maximum energy state of reactants is called activation energy. Reactions which take place by the absorption of radiations are called photochemical reactions. The total number of molecules which participate in reaction is called molecularity. In the mechanism of reaction, the slowest step is called rate of determining step. Now, next question is, explain the rate of determining step. Some chemical reactions complete in one or more steps. Rate of reaction is determined by the slowest step, which is known as rate determining step. Order of reaction is 0. Can its molecularity be 0? Molecularity of reaction is always whole number, thus it cannot be 0. What is temperature coefficient? Generally, rate of any reaction increases due to increase in temperature. On increasing temperature by 10 degrees Celsius, velocity of reaction is increased up to 2-3 times. If velocity constant of reaction is kT and it is increased to increasing temperature by 10 degrees Celsius, then ratio of these two constants is called temperature coefficient, and this is formula kT plus 10 upon kT is approximately 2 to 3. What do you know about molecularity of any reaction? Molecularity of reaction. The rate of reaction is determined by slowest step and it is known as rate determining step. Here, molecularity can be defined as number of molecules, atoms or ions participating in rate determining step is called molecularity. Example for unimolecular reaction, that is ozone to O2 in plus O. Bimolecular reaction, NO plus O3, NO2 plus O2. Now next question is, write differences between molecularity and order of reaction. Molecularity, it is the total number of molecules which participate in the reaction. This is the point, and its opposite point is for order of reaction. It is the number of molecules which participate in the reaction and whose concentration is not changed. It is theoretical concept. Order of reaction is determined by experimentally. It is always whole number. It is fractional values are also possible. Its value never zero. Zero value is possible. It does not provide any information about mechanism of reaction. It provides information about mechanism of reaction. You can also write this difference in table form. Write any four factors which affects rate of chemical reaction. The answer is, the rate of reactions depends on the following factors: concentration of reactants. At constant temperature, the rate of reaction increases by increasing the concentration of reactants. Secondly, temperature of the system. If the concentration of the reactants are constant, then the rate of reaction increases by increasing temperature. For 10-degree rise of temperature, the reaction rate becomes double or triple. Next, presence of catalyst. Positive catalyst increases the rate of reaction and negative catalyst decreases the rate of reaction. Next factor is nature of the reactants. In case of more simple molecules, the lesser is the number of bond breaking and the rate of reaction increases, whereas in case of complex molecules, more bonds are broken and rate decreases. Exposure to radiations. The rate of some reactions increases due to some special radiations. For example, if the absence of light, the reaction between hydrogen and chlorine is slow, but in presence of light, the reaction proceeds at faster rate. Next question, write a short note on activation energy. According to Arrhenius, any chemical reaction is only possible when reacting molecules are activated with minimum energy, which is called threshold energy. Kinetic energy of most of the molecules are less than the minimum energy. This excess energy, which is required to activate reactants molecules, is called activation energy. Activation energy can be determined by the use of Arrhenius equation, that is log K1 upon K2 equal to EA upon 2.303 R in bracket T2 minus T1 upon T1 T2. Next question is, write four differences between rate reaction and the rate constant. And here point wise you can also make table for this. Rate of reaction, it is expressed in terms of consumption of reactants or formation of products per unit time. It is proportionality constant in differential form in rate law or rate equation. It depends on concentration of reactants at particular moment. It is independent of concentration of reactants. It generally decreases with the progress of reaction. It does not depend on the progress of reaction. Its unit is mole per liter per centimeter. It changes according to order of reaction. Next question, prove that half-life period is independent of the initial concentration for the first order reaction. Or another question for it is, derive expression for half-life for the first order reaction. Both have same solution. Let us see. Half-life period for the reaction is that period in which the initial concentration of reactants is reduced to half. We know that first order reaction can be written as the K equal to 2.303 upon T log 10 A upon A minus X. At half-life, the value of X becomes A upon 2, half of initial concentration, and time interval becomes T half. Putting these values we get here k is k 2.3030 copy t converted into t half, and this is log 10, copy it. A is a. Now this a is copied here, and the value of x is a upon 2, so it is written a upon 2 in the place of x. On solving this, we get 2.303 upon t half and log 10 and 2. On solving this, we will get 2. Again, k is written here and it is also written here. T half is also written here. The value of log 2 is 0.3010, so it is the value of log 2. Now on multiplying this, we get 0.693, and on transposing t half this side and k this side, we get t half equal to 0.693 Kelvin upon k. Thus, the half-life period is independent of the initial concentration for first order reaction. Now, next question is, what do you understand by order of reaction? Give example. The order of reaction is defined as the sum of all the powers to which concentration terms in the rate law are raised to express the rate of the reaction. Suppose there is a general reaction AA plus BB plus CC and raised to product, for which the rate law is rate minus dx upon I, dx upon dt equal to k, a power p, b power q, c power r. Then the order of reaction is sum of these powers. This is n equal to p plus q plus r. For example, decomposition of ammonium nitrate occurs as follows. This is rate of reaction minus dx upon dt equal to k NH4NO2. Here the power is 1, so the order of reaction is 1. This is example of order of reaction, first order reaction. Derive an expression for rate constant of first order reaction. The reaction in which rate of reaction depends upon the concentration of 1 mole substance are called first order reaction. Let this reaction is A and equals to product. Suppose initial concentration of A is A gram mole, and after T second it becomes X mole consumed, and remaining concentration is A minus X gram mole. So after T time the rate of reaction will be proportional to A minus X, and it can be written as dx upon dt proportional to A minus X. After removing proportionality sign, we take a constant, that is k. K is velocity constant. On transposing dt here and a minus x here, we get dx upon a minus x and k dt. This is equation second. On integrating this equation, we take integration for this. After integration, we get minus natural log a minus x equal to kt plus c, where c is integrating constant. If t equal to 0, then x equal to 0, putting the value of c from equation second in equation x equal to 0 and t equal to 0, then we get minus ln a equal to c. It is a value of c. Now this value is putting in the equation third, we get here minus ln is copied, a minus x is also copied, kt is also copied, and the in place of c we put minus ln a. Now transpose minus ln a here, we get positive value and it becomes ln a minus ln a minus x. This can be written as ln a upon a minus x kt. If we find value of k, then t can be transposed this k equal to 1 upon t ln a upon a minus x. Changing the base of log up to 10, we get k is equal to a k copied, t is also copied. If natural log is converted into log of base 10, then the value is 2.303. So it is written as 2.303 upon t log 10 a upon a minus x. This is the expression for first order reaction rate constant. Now numerical question for it. A first order reaction takes 40 minutes for 30% decomposition. Calculate time. Let 30% decomposition means that x equal to 30% and a is equal to 0.30 a. As reaction is of first order, then formula is k equal to 2.303 upon t log a upon a minus x, and it can be written as here k 2.303, value of t is 40 minute, log a is a, and a is also a 0.30 a. On calculating this, we get k equal to 2.303 upon 40 log 10 upon 7 per minute. After putting value of log 10 upon 7, we get 0.1549 per minute. And by solving, we get k equal to 8.98 into 10 per minus 3 minute per minute. For first order reaction, T half equal to 0.693 upon K. By putting value of K, that is, we have find 8.981 into 10 power minus 3, put this value here, and we get T half equal to 7.7 minute. This is the half time for the decomposition of this reaction. So these are the important questions, and you have to practice it, share it, and subscribe the channel. Thank you.